Okay, do you see my Canvas screen?
Yes.
Okay, good. All right, so this is Canvas and here are your links, my links anyway, but it looks like yours. And if I want to go into your class, so if you want to go into your class, you would click on whatever you call your link that's our class. And this is what you would come to, very first thing, right?
Right.
Let me go to student view. This is what you would see. That's what students see. Hello?
Yes.
Yes. Okay, now if you come down here, here's our class link. That's where you are right now.
Yes.
And if you come down a little further here, do you see my mouse?
Oh my goodness.
Yeah, that's it. That's where you click to do my office hours starting at 3.
Okay, I was looking in the wrong place then. Usually whenever I meet with my other facilitators, I have their contacts. So on Microsoft Teams, it gives us contacts, and we have to look up your name. And so when I was looking up your name, I couldn't find you. So I was like, I don't know what other way. So I decided to send you a message, and I was like, maybe she can send me a link.
I don't know what you mean by contacts, contracts.
No, contacts. So in Microsoft Teams, you have this thing called contacts. If you go to your calls, it gives you a list of your facilitators.
Oh, okay, okay. And
Yeah.
I'm not there because I am one of your facilitators, I believe.
Yes.
Well, that's interesting that you couldn't find me. I feel bad now. But
Oh, it's
anyway,
okay.
now you know how to find me.
I do now.
Yay!
Yay.
Okay, so let's start with solving systems. Okay, the system stuff that you're going to do in your classes is all related to a form of business, that is a business discipline called logistics. It's a very good place to get a job in any firm that does logistics. This is the beginning of it. If you can imagine two trucks on two highways, and it's your job to find out where those highways cross so that the two trucks can pull over and they can trade loads. You know, like maybe one's got a box that should have been on the other one. So, I mean, that's just one purpose of it. What we do when we solve these systems that consist of 2 lines and 3 columns, this is called a 2x3. A 2x3 system. And in real life, most often it's used to find where 2 roads intersect. So that you have X and Y, instead of X and Y, you might have latitude and longitude. But this helps you find them. All right, now, once we solve our system, we'll have a point, a number in front of the X, and a number in front of the Y. And that's our goal. So here we go. We're going to use something called row operations. And row operations are ways of adding 2 rows or subtracting 2 rows. multiply 2 rows by a constant. And you can even substitute one row for another. I don't do that very often, but you can. Okay, so that's row operations, and that's what you do when you're trying to solve systems. Not all systems have a solution, but the ones that I'm working with do have a solution. And you might remember this from beginning algebra, because you did this in beginning algebra. There are 3 ways to solve a system. You can solve it by graphing, you can solve it by substitution, or you can solve it by elimination. With this system, you have to use elimination because it's just too hard to get it into a substitution form or get it into a y equals form, which is what you would need to be able to graph it and find a solution to the system, which is the point of intersection. So that's not a negative. So I'm just going to put X and Y because I don't want somebody thinking that's a negative. Maybe I'll get rid of the whole thing. The solution of the system, let me write that. That's the solution of the system. It's the XY point of intersection. There. Okay, so I'm going to save that. Okay, now the goal is for me to be able to add the X's together and get a 0, or if that doesn't work, add the Y's together and get a 0. That's not going to work here. So what I have to do is multiply 2 of the rows by a constant so that you'll see what happens. I am going to, and here's my recipe. We call this the recipe or the strategy. It's your plan to change the system in such a way that you can solve it. And I am recording. But let me make sure, because I get so paranoid about it. Yes, 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 yes. Okay. Always worry about that. Okay, so this is what I plan to do. I'm going to label the top row line 1 and the bottom row line 2. And here's my plan. Here is my strategy, what I'm going to do to solve this system. I am going to multiply line 1 by 7. That means everything in line 1 by 7. And then I'm going to add that to the second row, but I'm going to multiply every number in the second row by 2. So I'll have 7 times line 1 plus 2 times line 2. That's my strategy, and you'll see why in a minute, if you don't already know why. If you remember doing this, maybe last semester or the semester before, then you know exactly why I'm doing this. My cat is sticking her claws into my stomach, his claws, and I don't like it, so I'm pulling my sweater shut. There you go. Okay, so 7 times line 1 is going to be 7, and I'm going to be multiplying 3x plus 2y equals 6. I'm going to multiply every number in there by 7, and then 2 times line 2 is going to be 2 times 5x minus 7y equals 13. And here's what that does for me. Makes me very happy. 7 times 3 is 21. 7 times 2 is 14. And 7 times 6 is 42. Down here, 2 times 5 is 10. And 2 times minus 7 is minus 14. And 2 times 13 is 26. And now I'm going to add these together. Notice that now that I have multiplied both lines by a constant, and a different constant at that I now, when I add, I'll have 14y minus 14y, which is 0, y, which is 0. Over here, I'll have 21x plus 10x. That's 31x. And I'm going to say plus 0y equals 2 plus 6 is 8, and 4 plus 2 is 6. So 31x equals 68. And when now I'm going to solve for x by dividing by 31 on both sides. And so x is going to equal 68 over 31. Now, I am not certain that that fraction is in lowest terms, and it has to be for my answer to be correct. So what I'm going to do is call up my calculator. You can turn on your calculator. And I'm just going to do this. My fraction is 68 over 31. I'm going to type 68 divided by 31, and then click on the math button, and then frac for fraction is right up there at the top, and hit enter again, and I get 34 over 30. That was supposed to be 31. 68 divided by 31. Math frac inner. Nope, it's 68 over 31. Okay, so I just wanted to make sure I could not reduce it. Oh, it doesn't want to go away. There. It likes being a star. Okay, now if this were a nice number like 2 or 3 or 5, or even -2, -3, or -5, it would be easy to go back up here and substitute this number into one of those equations and solve for the other letter, which is y. I have to have a y also. However, I don't want to have to calculate 68 over 31. I mean, that's kind of ugly. So, look, Cat, please, get down. So what I'm going to do after I save, because I don't like the idea of losing a lot of data. Here's what I'm going to do. I'm going to solve the system again. And this time, instead of adding and eliminating the y's, I'm going to add and eliminate the x's. So here I go. Let me do this. I'll have 3x, that's line 1, 3x plus 2y equals 6, and line 2 is 5x minus 7y equals 13. This time, my recipe E, my recipe, the joys of working at home, children and pets. There's no telling him no. Okay, I am going to do the following. I'm going to multiply every number in line 1 by 5. And I'm going to add it to every number in line 2 multiplied by -3. This is what I get when I do that. 5 times line 1 is going to be 5 times 3x plus 2y equals 6. And -3 times line 2 is going to be -3 times 5x minus 7y equals 13. And that is going to give me 15x plus 10y equals 30. And negative, nah.
I have a quick question. Why are we multiplying it by negative?
Your microphone is cutting in and out.
Why are we multiplying by -3?
The same reason we did it up here. In its present form, In its present form, I cannot add 3x and 5x together and get a 0. And I can't add 2y and negative 7y together and get a 0.
Mm-hmm.
But using the elimination method, I have to be able to do that. So when I can't do that, I'm allowed by row operations to multiply.
Know that, but why is it a -3?
Oh, because otherwise I'd have a positive 15x. I'll show you. If I had multiplied by a positive 3, I would have 15x down here.
So does it matter which one is the negative number?
No, I
Okay.
could have made it the top.
Okay, that makes more sense.
Okay, good, thank you. Anyway, with it being -3, I've got negative 15x, which is what I want, and the rest is like collateral damage or collateral blessing. -3 times -7 is positive 21. So 21y, and then -3 times positive 13 is negative 39. And so now when I add them together, I've got 15x minus 15x, that's 0x, plus 31y equals negative 9. And 0 times x is 0, so that means I have 31y equals negative 9. And then to get y by itself, because I'm looking for y, I'll divide by 31, and I'll divide by 31, and I will get the answers negative 9 over 31. Now, here's what that does for me. It tells me what y is. See, I have a kind of a blank space up there. Y equals negative 9 over 31. What that means is the solution of my system is ugly, is what it is. 68 over 31, comma, negative 9 over 31. And they usually have the same denominator, but not always, not always. So you have to be careful. Now, what we have found is the answer to a math problem, but in real life, we might have found the place where two roads cross. And it might be so that trucks can take a box off one truck and put it on another, or there might be some, I mean, there would be some reason because doing this costs money. If you're the owner of the shipping company, for instance, you've got to keep the trucks running, you've got to pay the people who are calculating this. So it's important that you're doing it, whatever your answer ends up being. And probably the answers in real life would be latitude and longitude. So you could find this place, maybe send in helicopters, maybe there's been a wreck. And so you're sending rescue helicopters. It could be any reason that this would be done, but it's a very common method used in business and in any kind of shipping that would have to use latitude and longitude. And it's called logistics. Okay, well, if we're on a life-saving mission, I hope we get there in time. Now, you were taught how to do this in beginning algebra. and you might or might not remember it, but you were allowed to keep the X's and Y's because you were new to math. You're less new to math now. And so here's the way we're going to really solve this problem. This is called a matrix. All a matrix is rows of numbers. You can even have just one row of numbers, and it's a matrix. However, here we're going to use row operations to do the same thing that I just did up there. But when you're doing row operations, they're done in a certain order. So like I wrote up there, this is a 2x3 system, which means it's a 2x3 matrix. 2 rows, 3 columns. This is row 1, and this is row 2, and this is column 1, and this is column 2, and this is column 3. And you know that these are the coefficients of the letters, so this part of the matrix is called the coefficient matrix. Matrix. When you stick this row onto it, it takes a new name. This is called the augmented matrix. Augmented means added onto, so you had a column added onto the coefficient matrix. And here's what we're going to do with a coefficient matrix. Like I said, we have to follow certain steps. Up here, we could just use any steps we wanted to, provided they were legal. Over here, I'm required, Cat, I really wish you'd behave. We are required to take this 5 and turn it into a 0. But we can't just go, poof, you're a 0. We have to use row operations to make that happen. And we're going to use another row operation you have never used, to my knowledge, and that is to substitute one row for another. Because when I get my answer, I'm going to substitute that row for what we're now calling row 2. So in a sense, I'll have a brand new matrix. It doesn't feel like it should work, but it does. And there have been proofs, you know, in upper level math, proofs that it's really true. It really does work. And we already know what the answer is, so we can check and make sure. All right, so here we go. The first thing I need to do is get a 0 in this position, and I'm going to do it with the row operation I just used. I'm going to take 5 times row 1, and I'm going to add it to -3 times row 2, so that when I add this to this, I'll have 15 minus 15, and I'll get 0. I mean, that's the whole reason. This is called the recipe step. I'm sure there's I'm sure there's a fancier step, a fancier name, probably strategy, but you know what? Almost every book I've read calls it recipe. So we're going to have this, and what this is going to become, so this includes an arrow like this, and that means what this is going to become is the new row 2. So that's my strategy or recipe step. So now here I go. I'm going to do this again. 5 times row 1. Well, wait a minute. 5 times row 1. And -3 times row 2. All right, 5 times row 1. 5 times 3 is 15. 5 times 2 is 10. 5 times 6 is 30. -3 times 5 is -15. -3 times -7 is +21. And -3 times 13 is -39. I add these two together, and I get 0, 31, -9. And this is what I do with it. The matrix I start working on is matrix number 1. I then go to matrix number 2. Matrix number 2 is going to have exactly the same numbers as matrix number 1 in the first line. But the answer, you recall, is going to be the new row 2. So this and this, yeah, and this are going to go here. And this is going to be our new row 2. I mean, our new matrix 2. Now we're going to do something called back solving. This is called Gaussian elimination, this method. Gaussian elimination. And you get your system down to here, and then you back solve. Okay, so we rewrite the matrix as a system. Okay, we've got our first answer, y equals -9/31. Now, see how much farther down I can go. I'm going to move over here. So I'm going to take this information and I'm going to work with it over here where I have more room. I now am going, now that I know what y equals, this method says this is what I have to do. Go up to line 1 or row 1. Okay, I'll write this first. Okay, I am, this, you see, it's so much faster to do this by hand than it is to pull out the calculator. What 10 times -9/31 is, let me show you why it's fast, just in case you don't know. 10 is 10/1. Same thing if you put it in the calculator, it equals 10. And you multiply it by -9/31. This is going to give you 10 times -9, which is -90. So you'll have 15x minus 90/31 equals 30. And then I can add 90/31, and I don't have any idea why I did that or how I did it. Kind of pretty in its own way, but not what I need at the moment. Add 90/31 to both sides. And I'm going to use the calculator for that.
Miss Barbara,
Yes?
right there, where you slashed it, should there be a positive and not a negative?
I did. I put a positive down there. Let me get rid of the slash. Right here, I had a positive 10 times the -9. So that's negative. Oops, but I should have kept that 31 because it was 31. But no harm done. It magically appeared again. So I've got -90/31. Now I have to move it over with the other constant so that I can solve for x. So that's why I added it. Since it's being subtracted, I had to add it in order to get 0 here. Because -90/31 plus 90/31 is 0. Whenever you add opposites, you get 0. Oops, what was that? What did I do? No, I don't want to. Whatever I did, I don't want to. So 15x plus 0 equals this thing. And I am definitely pulling out my calculator for that. 30 plus 90 over 31. But I want a fraction, really. So no problem. I'm just going to go math, frac, enter. So I'll have that ugly number right there. Ugh. Equals 1020, 1020 over 31. And 15x plus 0 is 15x. So finally, I'll have 15x equals 1020 over 31. This number right here. Okay, now I'm going to divide by 15, but remember that dividing by 15 is the same thing as multiplying by 1 over 15. So because I want my life to be a little bit easier, I'm going to multiply this by 1 over 15 and multiply this by 1 over 15. And see, these 15s cancel, and so I'm left with 1x, which is just x. And now the calculator gets a chance to do what it was meant to do so that humans don't have to. I am going to take, and now notice I'm multiplying fractions, so I have to use parentheses. No way getting away with it. Go. Okay, here I go. 1020, 1, 0, 2, 0 divided by 31, close parentheses, times parentheses, 1 divided by 15, parentheses closed. Now I'm going to hold my breath and dance a whole bunch of times. Math, frac, enter. I knew it was going to be wrong, but it's not. Yes! 68 over 31. How do I know that's right? Because we got it before. X is 68 over 31. And y is negative 9 over 31. We did it. We did it. We solved by old-fashioned elimination from beginning algebra, and then we solved it by matrix algebra, which is what we're studying now. So everybody clap. Yay, yay, yay us, yay us. This, ladies and gentlemen, is matrix operations. Working on a matrix to come up with a solution. And here's a real matrix. But we can go back here first. Kind of awesome, isn't it? Well, it can be kind of breathtaking. It's certainly true. Now, we're going to do this from scratch. Actually, matrix operations, row operations, whatever you want to call them, they were not meant to be used on a system this small. I mean, you can solve it more easily and more quickly just by doing it the beginning algebra way that you learned 1 or 2 semesters ago, or maybe a little longer ago. But now, oh, our story is going to change too. Here we've got 2 roads intersecting, and there are trucks. There's a truck on this road, and there's a truck on this road, and we need, because we work for J.B. Hunt, we need to find out where our trucks can meet so that they can take a box from one truck and put it on the other. Simple. It's not simple anymore, children. We are now dealing with 3 dimensions, which includes the air around us. Length, width, and depth. We are creatures of 3 dimensions, not just 2. Blackboard characters, little stick figures you write on a whiteboard. Those are 2-dimensional, and their locations are described by X's and Y's, but not these. These are not, because you're going to, if you're looking straight at the board here, if you have your Y-axis and you have your X-axis, coming right out of the board at you is the Z-axis. Because everything in our world has 3 dimensions. It has length, it has width, and it has depth or height. So the story we would use for this is there's an enemy missile headed toward the United States from who knows where. But it's headed toward the US. Excuse me. Here, I tell you what, my rockets are guaranteed to never ever fly. So don't worry about them. Enemy, I'm going to write enemy. Enemy. E-N-E-M-Y. And what do? We send 2 missiles up after them. Da 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 da! Gotta have sound effects. And yeah, I'm getting lost here. I'm so excited by the story. Like one comes from one state and one of them comes from another. Here's the one from the other state, and they're going after this guy. He's not going to get to land. Boom, boom, boom. Now, what this matrix might be representing is the flight path of these 3 missiles and where exactly in space, well, I mean, in our atmosphere, but in 3-dimensional space, where are they going to meet and explode this guy long before he's ever over US territory? That's what that does. That's one of the things it does. But that's more exciting than the other possibilities, which are how much material to fill up a truck with, or an airplane. You know, like how many of this kind of load and how many of this kind of load and how many of this kind of load will maximize the space used and at the same time minimize the cost of shipment. And it's used that way more by Amazon and the other big shipping companies, Walmart. Okay, you've got a 3rd letter now, Z. And so this is the X column, this is the Y column, and this is the Z column. And when we write this as a matrix, we're going to write the coefficient matrix, -4, -9, -1, -8, everything's negative. -6, -2, finally 6, 9, 1. This is the coefficient matrix, and then this guy is going to get added onto it to make this an augmented matrix. 24, 24, -26, this is row 1, this is row 2, and this is row 3. Okay. Now, a few notes on this. A few notes. There are some weird things you have to do. And somebody is bound to say, why do we have to do them? I asked that too when I was a student. The answer is this is a method created by Gauss. And you say Gauss with a certain awe in your voice. He's the biggest name in mathematics. He's had more of an effect on mathematics than anyone you can think of. He laid the groundwork for Einstein. So, yeah, we have to speak lovingly of Mr. Gauss, Dr. Gauss. Okay. In his system, what he discovered is we could come up with a solution. And incidentally, the solution of this matrix looks like this. It'll look relatively familiar. Now, what we've dealt with so far are solutions that look like this. This is a point on the whiteboard. It's got an X and a Y coordinate. But because you're dealing in 3 dimensions here, you've got an X and a Y and a Z coordinate. So back here, this is called an ordered pair. You know that. Another word for a point is an ordered. I really need to change to black again. Ordered pair. Well, this da-da-da-dum is not a pair. Pair means 2. This is an ordered triple. This is going to show the location, maybe at which missiles crash together, maybe. Or maybe just the answer you're looking for. But it's going to show it in 3-dimensional form. If any of you have ever watched the reruns to Star Trek, maybe they still do it, but do they still play 3-dimensional chess on the newer shows? On the old show, they had 3-dimensional chess. It was in 3 dimensions. This is like that. Okay, here is the order. Well, here are the weird things you have to do because there is no choice. It's the way you do it or else. The very first thing you're going to do with row operations is to make this position turn into a 0. So I'm going to put a 1 here. The next thing you have to do is make sure that you have put a 0 in this position, and you have to use row ops to do it, row operations. And then the third thing you have to do is put a 0 in this position. And after that, you start back solving. So let's get to work. After a drink of water. Here is my recipe for this is matrix 1. Right there. Here's what I plan to do. I plan to multiply row 1 by 2. Well, actually, it'd be easier if I just do it by -2. So I'm going to multiply row 2 by -2. That's because -2 times -4 is +8, so that I can say 8 minus 8 is 0. Now the rest just have to fall into line. I'm going to not do anything at all to row 2. And then the row that I get is going to give me my new row 2. So, -2 times row 1 is going to be 8. -2 times -9 is +18. -2 times -1 is +2. And -2 times 24 is -48. Now I'm going to just take R2 the way it is, which is -8, -6, -2, and 24. Now I'm going to add vertically. 8 plus -8, which is really 8 minus 8, is 0. That's what I wanted. 18 minus 6 is 12, or 18 plus -6. 2 plus -2 is 0. And -48 plus 24 is -24. Now at this point, I noticed something. There's a ding, 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 ding going off in the back of my head. 12 goes evenly into -24. Because it goes evenly into 24. I can take advantage of that before I go on. I can divide every term by 12. And what that gives me is 0, 1, 0, -2. And I'm going to put that in for row 2. So now I'm going to write matrix 2, and you're going to see a change only in row 2. Row 1 and row 3 are going to stay exactly the same. So we'll have -4, -9, -1, and 24. 0, 1, 0, -2, and 6, 9, 1, -26. Okay. Now, yeah, all right. Now I have to you were following my arithmetic. Did I appear to do anything like say 2 plus 3 is 85? Did I do anything weird? Except for the usual, of course. -2 times -4 is +8. -2 times -9. -2 times -1. No? Okay. Yep. Yep. Okay. All right. Just making sure. Always double check yourself. Now, the next thing I need to do is turn that 6 into a 0. Now, it's not going to do me any good to add row 2 and row 3 because 0 would just give me back my 6. So I'm going to work with row 1 again to put a 0 here. So let's see, I have 4 and 6. Both 4 and 6 go into 12. So if I take row 1, and it's already got the opposite sign, so that's good, and multiply everything by 3, that would give me a -12 there. And if I add this to row 3, multiplied by 2, then that would give me a +12 here. And if I make that my new row 3, we might actually get somewhere with that. Okay, so 3 times row 1 is going to be -12. 3 times -9 is -27. 3 times -1 is -3. And 3 times 24 is 72. So -3, is it negative? No, it's positive. So 3 times 24 is going to be 72. Now 2 times row 3 is going to be 12, 18, 2, and -52. So that'll be 0. Okay. This will be negative 9. Is that right? Yes, it is. Okay. I feel unsure about that. It's too late in the day. Blood sugar's going down. Better to double check, always. Negative 27 plus 18. Enter. Negative 9, yeah. Okay, negative 3 plus 2 is negative 1. And 72 minus 52 is 20. And this is going to be our new row 3. So we're going to have negative 4, negative 9, negative 1, 24. And 0, 1, 0, negative 2, and 0, negative 9, negative 1, yeah, okay, and 20. We're almost done. For those of you who are not finding this to be the most exciting thing, I know this is guaranteed to put your neighbors to sleep. If I could change it, I would, and have firecrackers going off in the back and stuff like that. Cheerleaders dancing. Yeah, I can't, so we'll just proceed. Now I need to change negative 9. This is a matrix 3, by the way. I need to change negative 9 into a 0. So I am going to add 9 times row 1, 9 times row 2, plus row 3. I'm not going to do anything to row 3. And this is going to be my new row 3. I get to do a new row 3 twice because I have to put zeros in there twice. All right, so 9 times row 2 is going to be 0, 9, 0, negative 18. And row 3 is 0, negative 9, negative 1, 20. And I will add these together. Okay, so we're almost done. We are almost done. We are almost ready to back solve. Patience. Zero, zero, negative 1, 2. That's my last matrix. Because now I start to back solve. All right, so we start off with line 3, line 1, line 2, line 3, and you can see pretty clearly that if negative z equals 2, then z equals negative 2. Meanwhile, this 1 and 2 zeros like that means that y actually equals negative 2, and there's no work that needs to be done for that. Now, the only place we're going to have to do some work is up here on line 1. Negative 4x minus 9y, but 9 is negative 2, minus z, but z is negative 2, equals 24. That'll be negative 4x plus 18 plus 2 equals 24. So it's negative 4x plus 20 equals 24. I subtract 20, I subtract 20. And I get a 0. So I have negative 4x equals 24 minus 20 is 4. And so coming over more toward the middle, negative 4x equals 4. Divide by negative 4. Divide by negative 4. And what you're going to get is x equals negative 1. So our ordered triple is going to be negative 1, negative 2, and negative 2. And that is the answer, because I looked it up before I did it. But I was worried for a while there.
Quick question.
Yes.
So right when we were about to solve like that last part where you did negative 9 times negative 2 minus negative 2, where'd you get the negative 2 from to put it in there?
Right here?
Yes.
Okay. From down here, y equals negative 2, so I knew that y was negative 2. So I put the negative 2 in for the y there.
Okay, I see. I just got a little lost. Thank you.
No, it's easy to do. It's very easy to do, to get lost. I'm feeling moderately lost myself. Anybody else? You've got to go home and try this for yourself. I'm sure you're all saying, oh, I can't wait to do that. But play the video 5 million times. I mean, that would be great. Well, it's 11:43. If you would like to leave now, feel free. If you've got any questions about all of this stuff, then by all means, feel free to stay around and ask. Or if you even have questions about older homework problems. It's hard to be older when we're only halfway through the second week.
When's our first exam?
5th week. If you look on the schedule now, it's there.
Okay. Okay.
You know, in my math lab?
Yeah.
If you go to my math lab, you'll see it.
Oh, okay. I was trying to look on the schedule somewhere on Canvas.
Ah, okay. No, if you look in my math lab, you'll see it.
Okay. Thank you.
You're welcome. Well, I'm going to save my document. Okay then,